All right, hey guys. So this is going to be the walkthrough for spring 2017 midterm one, problem number 5, and it's called Hoffery. So suppose we have the following generic HOF interface, public interface unary function T, and then it basically only has one method that you need to implement, which is the apply method. And apply takes in a parameter of type T, and does something with it, and it's kind of up to us what our more specific unary function is going to do with that object when we implement the class. Okay, so a spy now is a unary function that wraps around another unary function f, right? So for any input x, it returns the result f would return. That's the first key detail, right? It returns the result that f would return. So it does the exact same thing that f would do. But it also remembers the arguments on which it has been called. Okay, so that's sort of the additional functionality that's being added, along with the unary function that's being wrapped inside, which we're calling f. We're adding an additional functionality where it sort of like has a history. It remembers its past actions and can print them out on command. Okay, all good. So now there's an example down here. Let's just go through that really quickly. So let's say we have a unary function called sq, which takes in an integer. Okay, what this is going to do is it's going to basically square the input, right? So if we give it a 4, it'll print a 16. And now let's say that we pass sq, which is our unary function up here. Let's say we pass that into the constructor for the spy class that we're about to make down here. Now what's going to happen is we can call apply again, just like we could before, right? So we can call apply on this spy, and it'll print out the squares, right? So for 5, 2, and 3, it prints out 5 squared, 25, 2 squared, 4, and 3 squared, 9, right? But in addition to that, it also has this new method called print argument history, which isn't part of the unary function interface here, right? It's a completely new method. And what this does is it's going to print out the arguments that have been passed to it up to this point, right? So whenever we call it, it'll say, okay, I'll print out 5, 2, and 3, right? Because at this point, after calling these 3 applies, the history is 5, 2, and 3. Okay. So now we can get to actually building this class and sort of implementing the functionality that we've been given in this example. And yeah, so we have access to a working array deck or linked list deck if we need it, and we will. So the first thing I like to do with these class building problems on exams is I always like to get the easy parts out of the way, right? Because there's some lines in here that or almost exactly what's gonna have to go there, right? So one example is like this line right here next to the class header, right? So in this line, we know that it has to be either extends or implements, right? Because that's really the only 2 keywords that we've learned about that can go in that space after the name of a class. And sort of from intuition, we know that in the instructions, it said a spy is a unary function, right? Which means that it needs to implement this interface. So, through a little bit of deduction, we can tell here that this should implement unary function, which I'll just abbreviate from here on out as UF. Okay. And another easy one that I think we can get out of the way is in this constructor, right? So the argument for the constructor right here. So we saw when the constructor was called up in the example that we provided a SQ, an SQ was a unary function that was declared right here, right? And so we see that the parameter, the type of the parameter for the constructor for the spy object is going to have to be of a type unary function, right? Because that's kind of where the nesting happens, is we're giving it a unary function in the constructor. So again, we see here that this should be a unary function variable, and we'll call it func. Let me write that a little bit neater. Okay, so now probably the next step, and with class building things, after we get the easy things out of the way, it's generally a good idea to figure out how you're going to structure your constructor, since that's sort of like the home of your class. And then from there, after you've built the constructor, you kind of have a better idea of what's going on and how you might implement the other methods because you know what you have access to. So in this constructor, we know that we're going to need to have access to this func in future calls, right? Because this is really where the functionality is happening. If we want to implement the exact same behavior as the function that was passed in, the easiest way to do that is just to call that exact function that we were given on the argument. And I'll show you what I mean by that in a second. But basically, the important thing to note is that we probably want to store this function parameter in an instance variable, right? So let's do that. So first, in one of these lines right here, we're gonna have to put an instance variable, right? So we'll say it'll be of type UF T, and we'll call it function. And I made a mistake because that should be private. Remember that in classes in 621B, all of our instance variables are always going to be private. So private UF T. Make sure you can see this. Yeah. And then we'll just call this function. Okay. So we made one instance variable. And now with this instance variable, what we can do is we can assign it right here. So we'll say this dot function equals func. Right. And so now that we've done that, we've basically stored the function that we've been given in an instance variable for future use. And we'll see what that future use is in a second. Then we'll leave these blanks open for now. We're going to need to fill something in there later, but for now, we'll leave them blank and we'll focus on the apply method. So now that we've got this base functionality out of the way, right, we've stored this function. What we can do is actually start implementing the apply method, right? Because that's really where the main usability of the class comes, right? So let's do that. So once again, let's look at the examples that we were given to see what the behavior of apply is supposed to be. So if we're given an argument, we're basically supposed to do exactly whatever this function that was passed in, we're supposed to do exactly what that function would have done, right? So since the SQ function would have squared 5 when given the input 5, we also have to do the same, right? We also have to output 25 or 4 or 9 or whatever the, whatever the function inside here is. So if we're given an argument, and firstly, this argument will be of type T, and we'll just call it item. If we're given this, basically what we need to do is we need to return whatever this function would have returned. And since we have this function stored in an instance variable, it's pretty easy to do that, right? We can just say return function. Actually, let's make it clear. We'll say this dot function. What's the method called? Dot apply. Dot apply. And then we'll put item. Right, and basically what this does is this dot function is the function that we stored in the instance variable up here, right? And then we basically just called that function's apply method, and we know it has an apply method because it's a unary function type, and the unary function interface up here has an apply method, right? Okay, let me clean this up a little bit. So now we need to worry about the last part, which is really the unique part that the SPY class brings. Because so far, this does exactly what a normal unary function would do, right? But the additional functionality that the SPY class brings is that it also stores the history. And so to store the history, the best way I like to think about it is that rather than trying to figure out how to like backtrack or do any of that, once you get to the point where you call print, the easiest way to store something like this is like, every time you call the apply method, right, this apply method right here, you're also going to want to store what was called, right? So the easiest way to do this would be every time we're given a new item, maybe just add that item to something so that when we need to print it, we can just get that something, that data structure that stores all the items and print that out, right? And that should, and sort of, you might have gotten a hint about that from the fact that we've been given an array deck or linked list deck, right? These are both data structures that really have nothing to do with anything that we've just implemented. So it should kind of clue you in to say, okay, I haven't used an array deck or linked list deck yet, so maybe I might use that to store the history of my items, right? And so now that we know that we're going to want to use a array deck or linked list deck, let's actually make that an instance variable first. So private, and then we'll just use an array deck. And then again, the items will be of type T, and we'll just call this history. Okay. So now that we have that sort of set, always, when we have an instance variable, we're going to want to initialize it in the constructor, right? So when we build our object, we want a new array deck to come with it. So this dot history equals new, and then again, I'll just implement, or I'll abbreviate array deck here as AD. AD of type T. That's not where that goes, actually. There we go. AD, and like that, right? So now we've sort of implemented our new array deck. And then finally, so we talked about how the functionality should be that every time we call apply, we're going to add the item that we were given to this new history so that we can print it out at the end, right? And so that's going to happen right here, right? Because when we call apply, we're going to want to add, and then we can take a look at the deck methods over here. So we probably just want to do add last, right? Because every time we get a new item, we want to add that to the end of the deck so that when we print it out, the very first element in the deck is going to be the earliest one, which is the behavior that we want, right? So history dot add last item, right? And then finally, since now we know that whenever we call apply, we're going to for sure add our item to the history, all we need to do is print out that deck, right? The history deck. And so we have a very handy method for that, which is given to us right here, print deck. So all we need to do here is say history dot print deck. And since that's going to take care of all the printing for us, this should be our full solution, right? So basically, yeah, that's the I think the main point is that we need to have this data structure called history that is sort of built up over time as you call apply, and then you can just easily print that at the end to take care of all the functionality. And yeah, hopefully that was helpful, and I'll see you guys next time.